Welcome everyone to Module 12.3, Part 1, where we are going to be talking about uncorrelated subqueries. Now in Part 1 of this video, we're going to be looking at uncorrelated subqueries, and in the second video, we'll look at correlated subqueries. But in both cases, a subquery is a SQL query that is embedded within another SQL query. And so the inner query executes, and the output of the inner query is fed into the outer query, and the outer query does something with those values, just as if we had specified those values when we were writing that SQL query. So for an uncorrelated subquery, the subquery is executed first and then passes one or more values into the outer query. So if there's only a single value returned by this inner query, we can use our normal comparison operators like greater than, less than, equal to, greater than or equal to, things like that. And if a set of values is returned, we use operators like in, any, and all. And we should already be a little bit familiar with the in operator, and we'll have some examples with any and all momentarily. It's pretty straightforward. And then just like with our other operations, we can negate these using the not operator. So at this point, I'm going to bring up my Oracle interface here, and we are going to run some queries. So in this case, we have two relations, one that we're already familiar with, the course relation, and this is just the same as relation C that we looked at in the last video, where we have 12 courses that have a name, a course number, undergraduate or graduate credit, and then a department code for the department that offers that course. And then we also have a section relation, which has sections that are being offered of these courses currently. And I'm going to, just to make this a little easier to see, order this by course number. So you see we have multiple sections of some of these courses offered. So this course is 22 IS 270. We have two sections of that. We have three sections of 22 IS 330, four sections of 22 QA 375, right? So this is just like a normal college class where you have a course and you have multiple sections of the course. And not all courses are being offered in all semesters. So the way this particular query is going to work, where it says select asterisk from course, where course number in, and then here is our subquery, select course number from section. So this inner query is going to execute first and then provide a list of values, and we're going to select from the course relation all of the tuples where the value of the course number attribute is in that set of values. So this inner query executes first, and I'll show you what that's going to do. And one thing I should point out here, because I'll be doing this a lot in these examples, in SQL Developer, when you highlight a single line and run that, it runs just that line, not all of the SQL code you see. So when this query executes, select course number from section, we get this list of course numbers. And that list is, you can just kind of imagine this list being copied and pasted right into this set of parentheses. Right? And then we're going to select from the course relation where values of this course number attribute are in this list of attributes. And what this is going to represent are all of the courses that currently have a section being offered. And so I'm going to demonstrate that this is really doing the exact same thing here. So when we run this, we get this list of values here, which I could copy and paste. And I'm going to create a list of strings here. Just a comma there. Right, so we have this list of values, and we could actually just replace could just replace that inner query with this list of values, and you see we would get the same thing, right? So this is just like how we've used the in operator before to evaluate the value of an attribute against some set of values. But the difference here is that we are now dynamically creating that set of values using this inner query. And so now if new sections are added, that is automatically going to update this query without us having to update the set of values that we were passing into it. So that's a very powerful thing there. And then we can negate this using the not operator. So we would just say select asterisk from course or course number not in, and then here's our subquery. And that is going to tell us all of the courses that currently do not have a section being offered. Our all and any operators work together with greater than, less than, and equal operators in order to let us return values that are compared to either any of the values in the subquery or all of the values in the subquery. So let's take a little deeper look at what that means, and we're going to look at this professor relation for that. And so first I'm just going to pull up all of the data that is in the professor relation, and what we see here is that we have, can almost get it all in there, we have 20 professors that each have a department code. Most of them have a salary, but we do have 2 professors that have a value of null for their salary. So that's going to be important to remember in just a moment with some of our examples. So in this example, we want to select name and salary from professor where the salary is greater than all of the salaries of professors who are in department number 3. Okay, so if we run this query here, let's just say select asterisk from professor where D code equals 3. This shows us the 5 professors that are in department 3. And when we project only the salary attribute, we see the 5 salaries for those 5 professors. So these values are going to be generated by this inner query. And then we're going to look for all of our professors where the salary is greater than all of the salaries in that list. And what we're going to find is we have these 3 professors, Mike Faraday, Marie Curie, and John Nicholson, who have salaries that are greater than all of our faculty in Department 3. Now we could change this up just a little bit and look for professors who have a salary that is greater than or equal to all of these professors, and now we get 2 additional professors that have salaries of $77,000, which I think both of these professors actually are from Department 3 anyway. Now, one thing I will point out about this is if we're looking for professors that have a salary that is greater than all of the salaries from Department 3, another way we could think about this question is, well, if I have to be greater than all of the salaries, really all I have to do is be greater than the highest salary. So let me show you another way we could address this, this question. Is to say, use the aggregate function max. We want to select the maximum salary from professor where department code equals 3, and we find that's $77,000. Now if we take this subquery, or this query, and make that our subquery, we no longer have to use the all operator. We can just say select name and salary from professor where the salary is greater than the single value that is returned by this subquery. And, oh, can't have my semicolon there. And we get the same output that we got using the greater than all operation. So those are examples of using the all operation. Another operation we can use is any. Okay, so if we wanted to say, if we wanted to find professors that have a salary that is greater than any of the professors in Department 3, we would write something like this. Select name salary from professor where salary greater than any, and then this subquery, which again returns all of our salaries from Department Code 3. And the any operator is basically equivalent to saying we have a salary that's greater than the minimum salary in that department. So we should get a much larger list, of faculty members here, because they only have to have a salary that is greater than the lowest salary in the department that is returned from that subquery. In the PowerPoint slides, we have a really interesting question here. Will this return null values? And that is a really excellent question. So we've talked about a couple of times how null values just act a little bit weird and are difficult to deal with. So we can demonstrate that by just comparing the salary. So as I mentioned earlier, we have 20 professors in this table. And so if we, for example, wanted to find all of our professors who have a salary that is less than $100 million, which should be all of them, we find that we only have 18 professors that are returned by this query, not the 20 that we actually have in the table. And similarly, if we wanted to find professors that have a salary that is greater than negative 100 million, which they all should be, we get the same 18 records returned, right? So our two professors that have a null value for salary are never going to be returned by any operation that is comparing their salary to some value. And in order to get them to return, we have to use the is operator. So we could say select name and salary from professor where salary is null, and we get these two professors that have a null value for salary. So the answer here is no, none of these evaluations are ever going to return null values. And then could we write this using an aggregate function in the subquery? So instead of saying we want to find the name and salary for professors where the salary is greater than all, we could use our min aggregate function and just look for tuples that have a value of salary that is greater than the minimum salary of Department 3. So again, if we run this query, the subquery just by itself, we get the minimum value of salary from Department 3. Now, our final topic for uncorrelated subqueries is to use a subquery as part of our from clause, thereby creating what we call an inline view. So what we're going to do are select some attributes from one of our tables and then join that table to the relation that is created by some subquery being executed. So what we're trying to do here is to find the name, department code, and salary, and then the average salary for the department that professor is, and then return only professors who have a salary that is greater than or equal to the average salary of their department. And so what is going to happen when we execute this subquery that has an inline view is this subquery is executed first and creates in memory on our database server a view of the table that looks like this, where we have department code and the average salary from that department, and then it joins this table to the professor table in order to answer that question. So if we look at this in Oracle, I'm going to run our subquery first just to show you what that output is. Let's put our semicolon there. So the output of this subquery is our department codes and the average salary for the department, and we're going to join this relation to our professor relation. And now in the resulting output, we have the name of our professor, the department code, that professor's salary, and then the average salary for their department. And then we're only returning tuples where their salary is higher than the department average. So the subquery executed, created a view of the data, which we then joined to the table professor to create this output. So all of these tables currently exist on the Oracle server, so I would suggest copying and pasting or retyping these queries into Oracle and kind of playing around with things and seeing what it looks like. In the next video, we'll talk about correlated subqueries and get more in depth into all this. So see you there.